Hi, Jasper.
Hello, welcome. Over to you, talking about test coverage, I understand.
Thank you, Jasper. Hi, folks. Welcome to my talk on smart testing approaches for improved product quality using code coverage analysis. My name is Nick Medeiros. I'm a technical marketing engineer at FrogLogic. On behalf of FrogLogic, I'd like to thank our friends and longtime partners at KDAB for inviting us to this conference, and give a special thank you to the folks in KDAB Marketing and Charlotte Johansson and Jesper for their work in everything from organization to logistics to tech support and everything else. So thank you very much. So today I'll talk about ways to use code coverage to guide and inform your testing workflow. This talk, of course, will be given in the context of Qt applications, and we'll use our own code coverage software, Squish Cocoa, as our guiding tool chain. By the end of the talk, you'll know how to create an instrumented Qt application for getting the code coverage of that application. We'll talk about how to integrate a unit test framework for getting the code coverage of those suites. And I'll show you a GUI testing integration with Cocoa using our very own Squish GUI tester, which you may have seen if you attended my colleague Ferrick's talk yesterday. So we'll do all of this focusing on cross-collaborative teams. So this talk is not just for the developer, knee-deep in source code, but also for the test engineer, the DevOps folks, product managers, and everyone in between. So let's get started. So just a few notes about who I am. So I've been at FrogLogic now for 2 years, working in our marketing department. My background is not so much in software, but rather in chemical engineering. And my graduate research was on simulations and computational mechanics. I'm from the US, currently living west of Boston, though I did spend a few years living in France and in Germany. And some interest of mine include speaking French, though I don't get to do that very much here in Boston. I'm a big poetry fan. I don't know how big Subarus are over in Europe, but I'm a proud Crosstrek owner. And when inspiration strikes, I like to run, although very slowly. Okay, so let's get into the meat of things. So what is Cocoa? This slide sort of summarizes Cocoa in very broad terms. So first, the question is, what do we mean when we talk about code coverage? Not just the idea behind code coverage, but the hope behind code coverage is that source code that has been hit by tests, in other words, our tests which have touched our source code in some way offer a lower chance of defects being found in the final product. And Cocoa can analyze and identify the code that's been executed by our tests. And with that, it can also report on the untested code, meaning it'll tell you where you might need to focus your efforts in order to get a higher coverage from your tests. Cocoa can also identify redundant tests. We'll see a way to eliminate those redundancies automatically later on, but this helps you write more efficiently and minimizes time requirements in the pipeline. And Cocoa can also identify dead code, which is code which is never reachable, and it has a tool built in to extract the lines of dead code for any size project for rapid editing. But that's code coverage analysis. Cocoa also supports code metrics, including the McCabe cyclomatic complexity metric and the effective lines of code. And those metrics can be used to tell you the maintainability of your code, the testability of your code, how if it's well structured and suited to testing. And new to Cocoa 5 is it has a built-in function profiler where you can assess application performance. So it works similarly to any other function profiler, in that it'll give you data regarding the frequency and duration of function calls associated with your executions. And this data can be used to tell you if you need to, it can identify performance slowdowns and let you know where you might need to refactor your code. A cool feature about Cocoa is that it supports comparisons between product versions. So you can analyze and compare current and candidate releases. And this is good. You can do this with and without the use of the function profiler. And Cocoa has other features for optimizing your testing, which we'll touch on later on. But the next couple slides will cover coverage levels Cocoa supports, and we'll get into instrumenting a Qt application. So these are the coverage levels that Cocoa can report on. Many of these are probably familiar to, the typical software developer, and the names kind of give them away. So in function coverage, we count which functions were called and how often. In line coverage, we count the number of executed lines. We compute the coverage percent, rather, by taking the number of executed lines and dividing it by the total number of lines. But the two that I wanted to mention specifically that are not standard in Cocoa's instrumentation just because they're more complex is MCDC and MCC. So in MCDC, or modified condition decision coverage, it's like condition coverage, and in condition coverage, each condition has to take all possible outcomes. But the key for MCDC is that each condition by itself has to be shown to act on the decision outcome, everything else being held fixed. So what does that mean for when we're testing? Well, the key part is that every condition in the decision must be tested independently in order to reach full coverage. And MCC, it's multiple condition coverage, so all combinations of truth values in each decision must occur at least once to reach full coverage. And when we talk about safety critical applications, for example, if you're working with functional safety in automotive systems, which is the ISO 26262 standard, you'll note that MCDC is, quote, highly recommended, aka it's 100% required for the unit level, and that's because of its strength in compared to decision or condition coverage. Like I mentioned, MCDC and MCC are not sort of turned on by default in Cocoa, but we can add those in when we specify our instrumentation instructions. So this slide talks about instrumentation of a typical program. The diagram that I have shown here is sort of a modified program compilation. You see the usual stages, except that we have the coverage scanner, which is a backend program of Cocoa within our diagram, and a new file called the CSMES file put out by the linker. So Cocoa is made up of two main programs, one of them being the coverage scanner, and its job is to insert instrumentation instructions into the pre-processed code. And when we modify our project in order to instrument it, what we'll do is we'll modify the Qt project file in our application, in our example application. We replace the compilers used to build the executable with the coverage scanner's compiler wrappers. And at the linking stage, Cocoa creates what's called an instrumentation database, or a CSMES file. This is also referred to as the coverage measurement file. Among other things, it stores a copy of the whole source code. And one thing I want to point out is that during this instrumentation process, we're not modifying our program's source code. It's in our Qt application that we'll see later, it's handled entirely in the project file. So moving on to execution, any use of the instrumented binary that is produced from the instrumentation stage from the coverage scanner will result in a second file called the execution report, or the CSEXE file. And when I say any use, I mean it could be as simple as opening and closing the application. It could be running a suite of unit tests against it, manual tests, automated GUI tests, automatic tests, things like that. And when we want to view the coverage reporting, this brings me to Coco's second program, which is called the Coverage Browser. So the Coverage Browser is Coco's main UI. It's used for interactive browsing through the coverage data. And in order to do that, you need to upload both the execution report and the coverage measurement file into the coverage browser. And then you can browse your results interactively. It's used for managing executions, various analyses. You can create reports, export reports, spreadsheets, and do quite a bit more with it. But we'll see that in a few minutes. So I want to move on to an example. I'll use the Qt text edit application. It's a simple text editor, and we'll talk about how to instrument it through the Qt project file. And then we'll take a look at some different testing strategies that are typical in a team. So first, I just want to handle the instrumentation just through the slides here. So this is my additions to the Qt project file that came packaged with the application. We want to be able to build our app in a normal way and then in an instrumented way. And you can do that. We're compiling with QMake, and you can do that with a QMake scope. So we've created a coverage scope called code coverage. And these additional lines basically customize the code coverage. So the first one gives the name of the instrumented binary that will be produced. The second and third are expressions for excluding files from the code coverage computation. So for example, we don't need the resource files to be counted in our coverage instrumentation, so we exclude those. Here we set the compiler and linker flags. And finally, we instruct QMake to use Coverage Scanner's compiler wrappers, which I mentioned earlier in the instrumentation diagram page. This is how the Coverage Scanner works. We need to replace the standard compilers with the Coverage Scanner compiler. So you can see it's a little bit hard to see here where it's kind of small, but we've just prefixed a C and an S for Coverage Scanner before the statements. And I've done that for everyone except for the QMake CC, which just to show you that I'm using the G++ compiler. And that's it. And when we go ahead and build our app, which we'll see at the command line in a minute, we just issue QMake with our code coverage scope as a call to configure and issue make. So we'll get to using Coco now. And I wanted to involve multiple roles in this presentation, so I don't want to just talk about unit tests alone for the developer or automated GUI tests for the QA engineer or the manual tester. We'll look at all three, and I do want to say that this is a little bit of a contrived example, so it's not typically the workflow that you would have in a typical application, just because it's a very simple, basic application that could stand for some work on its own. But okay, so let me share my screen. Okay, so here is my application, and I've edited the project file here to have like we just covered. And I'll go ahead and compile it. And if we go into our app bundle, I'm on Mac OS, we see that it created the textedit.csmes file. So it created that coverage measurement file, which we'll need. And I'll just go ahead, we'll do an interactive test first. So I'll go ahead and launch the application. And it's a simple text editor that you can see here. So we could type something. We want to look at saving a file, which we'll look at. But for right now, we'll just open and close the application. And we should see right there, we see the text edit execution report. So let's open these up in Coco's coverage browser. Open and close. That passed, we'll set pass there, and we see our execution import summary, and we can open it. So this is Coco's main UI. Right away, we see the computed coverage percent. We can cycle through the different coverage levels, function, line, statement, and condition coverage. And if I open up, I have file save as already up here. If we take a look at these two functions, file save and file save as, we see that they're colored in red, which is this source code viewer is Coco's visual explanation for the coverage of your source code. So red indicates that no tests have executed this code. So what we want to do in subsequent tests is we want to be able to get all these to green and get all these to 100% coverage. So, and we'll do that through unit testing and through automated GUI testing. So let's go back to our app bundle. Let's open up the app again. We'll choose save, and we get the save as pop-up, and close out of that. And Coco recognizes that the execution report has changed. So let's choose a new name for this. Save OK. Passed. Import. And we see in the file save function that part of our condition has turned green, which means that it was executed by our test. If we take a look at here, this line, we see the file name is empty, is covered in is colored in orange. It's partially executed, and if we hover over it, we see a truth table. So the true case was evaluated one time by one test, and the false was never evaluated. Similarly, in our file save as function, we have no test to cover this. So we'll do that with an automated GUI test. So if you guys attended Frederick's talk yesterday, he showed you the Squish GUI tester, which is an automated GUI testing tool with specific support for Qt applications. What I've done here is I've simply supplied to Squish an application from the text edit application, but it's my instrumented application, not the normal build. And the way this Squish Coco integration will work is that when I run my GUI test from Squish, a execution report will output automatically. So what I've done here is I've just written a few tests that test the file save as function. The first one saves an empty file name, and then the next one covers some conditions in the code, like if you save with a garbage file name, file extension, it will automatically change it to a .odt file. Then you need to save the HTML case, the HTML case, and the ODT case. So if I run these cases, you'll see our application. You'll see our application under test execute. we're going saving the files. Cocoa recognizes that the execution report has changed. And in Squish, Squish reports that all the tests passed successfully. So if we go back to Cocoa, GUI tests, you can see I've done these a lot. GUI tests, save as, they passed, and import those. And in our coverage, we see that we've successfully covered the whole file save as function in an efficient way. So we've not written too many tests, and we've not written too few tests, and we've done this by being guided by the code coverage analysis. One condition that's left is this if success statement. So the false has never been evaluated, which means we've never unsuccessfully saved a file. So we need to save an illegal file name, which we can do. It's a little tricky to do from Squish. It is possible, but on a Mac it's tricky. One thing I want to show you is doing it from a unit test. So let me just go back to my slides. So we want to incorporate unit testing into our workflow, and we will do that using the qtestlib library. And in order to do that, our unit test, we need to instrument our unit test in the same way as our application. So on the left, you see the unit test. It just saves an illegal file name. Here you see the / here, which is illegal on Unix and Mac OS. And on the right is our infrastructure for managing our tests. So not so important when we're only dealing with one test, but it would become more important with several. What we're doing here is we're integrating our unit test framework with Cocoa in order to save the name of our test, save the coverage data, import its execution status, whether passed or failed, and do this for any number of tests. So I'll show you that now. So you folks should be able to see my screen again with Cocoa, and I will open up. So I have we want to compile this unit test, so I will do similarly. Here we're compiling our instrumented unit test with our older application, and we'll make it. Now, what I'm going to do is I'm going to execute the test manually, but you could set this up with build rules to have it be executed automatically, but just for a demo purpose, we'll just, let's kind of handle all behind the scenes in a file, but we'll just do it manually once it builds. So if I go into the app and I execute my application, we see our test save file, our unit test executed, and because of our infrastructure, Cocoa will recognize the name of the test and also its status, whether passed or failed. And here it also records the time. So let's open up, we'll load an execution report. And this is unit test 2, hit pass. Here we see that the test file name, the test name was saved and imported into Cocoa along with its status. And this is not known to Cocoa. This is from our work in our infrastructure. And we can import that. And if we go back to the file save condition and the file save as condition, we see 100% coverage for both of them. So again, this is sort of a contrived example where we are using a very basic application, and we're looking at the coverage and going back and forth between our tests. But the idea is that we're using code coverage as a guide for our testing efforts, and not doing more testing than necessary. Which brings me to a point that I'd like to get to on another slide. Let's talk about first test case prioritization. So I'll go back to continuous integration in a second, but test case prioritization is a method to eliminate redundancy. So Cocoa has a feature built into the coverage browser where if you have a list of tests like we have here, where we combined our manual testing, our unit testing, and our automated GUI tests. And let's consider a development problem where we have a lot of tests in a large suite and we don't have enough time to run them, but we need to do some amount of risk assessment and some testing. What you can do with Cocoa is you can optimize the execution order. What it does is it'll output a list of tests where it gives you the test, it'll give you a list of tests, and the first test is that which gives you the highest coverage in the shortest amount of time. And the second test is that which gives you just a little bit higher coverage, and third, and so on, and fourth, and so on. And you might recognize that it reduces the total number of tests that you have in your list, and that's because it eliminates redundancy. So Cocoa detects when your tests have covered the same lines of code more than once, and it eliminates them from the list. So basically what you're doing is you're scheduling tests to maximize coverage efficiency. Another feature that's really great is test impact analysis, which Cocoa can do. So another development scenario where you have a last-minute fix which must be evaluated, but you don't have time to run a full suite, but you need to do some kind of risk assessment. Cocoa will tell you, it'll help you determine which tests exercise the changed code and run only those. This is what we call this patch analysis, but it's Microsoft coined term as test impact analysis. I just want to go back to one slide about continuous integration. Let's talk about a problem that folks are having in development teams and DevOps teams. It's that there's an increasing demand on quality in ever-shortening release cycles. And the adoption of a DevOps process in modern agile teams has really bolstered the use of continuous integration systems for improving quality control. And using code coverage tooling, we'd want to integrate that into our build and test infrastructure for fast feedback on the coverage. And with Cocoa, you can do that. Cocoa supports popular CI solutions. We have dedicated setups for Jenkins and Bamboo and SonarQube. But if we take the Jenkins Cocoa integration, for example, with it, you can view the updated coverage over time. You can also set thresholds, set coverage thresholds on your build, pass, and fail. So, for example, you'd say pass this build if it meets this coverage with a new check-in, and fail it if it doesn't. And it gives you that fast coverage that fast feedback on coverage that development engineers are looking for. And one other topic I wanted to talk about was black box testing. So there's a growing market for outsourcing your QA team to, manual or automated testers all around the world. And a problem that happens is that with Cocoa, the coverage measurement file has a copy of the source code. And so in teams where source code security is a top priority, and not even all developers on the team have access to the full source code, you need to be able to have your QA team help you with your code coverage analysis. And what Cocoa can do is it generates a black box database. The black box database can be passed to QA, and you ship the instrumented build to QA. The black box database has no record of the source code. However, what you can do is the QA can still run their tests. They can import their executions. They can comment on their executions and get the coverage level, get the coverage computations, but without any source code. And what the developer does with master access to the source code is that they can collate QA's reports into one master report. So they collect all of QA's combined measurement reports into one, and it has the source code. This is good for if you have a team of testers spread around the world, or you're outsourcing them to another company, and source code security is of serious concern. That about wraps up my presentation, about 35 minutes in. So just a few words about Cocoa. You can find more about Cocoa on our homepage, froglogic.com/Cocoa. Of course, we offer evaluations if you'd like to try the tool. We don't limit any features for evaluation versions, so you'll have full support in Cocoa. And our online docs can be found at doc.froglogic.com. And we encourage you to stay in contact with us. So if you need to reach us via support, contact us at squish@froglogic.com. My email, I give it on the first slide, but again, it's just my first name, Nicholas@froglogic.com. And we're on, the big social media sites, including YouTube, where we post videos and developer tips, upcoming product news, company news, where we'll be presenting and stuff like that. So with that, I'm a little bit short, but we can move on to the Q&A.
Thank you very much. So I'm just wondering if there's any integration between Squish and Cocoa regarding calling the other tool, or whether it's a purely manual process. Go to Squish, run your test, then go to Cocoa, launch, and make sure that it finds the file and so on. And
before the process was manual, which required scripting in order to get the two tools to communicate. Now, and what I showed here is that they exchange their information automatically. So okay. The Squish and Cocoa integration works now successfully for Qt applications, for the Qt framework, but that's handled behind the scenes. So there's no external scripting that you had to do before.
Okay. Hello, Harry. Okay, so for the rest of you, Harry is one of the founder of FrogLogic, the company behind Cocoa. So you showed us how it works with QMake. You gentlemen might not have noticed, but the rest of us has moved on to CMake. How is QMake support with?
Yes, we have support for other build systems. CMake is supported. We have documented setups for using it in our documentation with Cocoa. So CMake is supported, so is QMake.
Okay.
Visual Studio or whatever, yeah.
Do you often find companies which have absolutely zero tests, and how hard is it to convince them that it's a good idea?
Yeah, maybe that's something that I can answer, because I'm indeed running into such cases. Of course, it's not zero coverage, at least, so there's usually something, but everybody gets very disillusioned on the first measurement that maybe your coverage is like 10 or 20%. that's a reality. One has to live with that. And unless you're in a safety critical environment, as Nick mentioned, you may never reach those 100%, but it's never too late to start. And one shouldn't also try to cover certain parts blindly, but go for those things that are most importantly. So the code complexity measurement that was mentioned can help you to find the most risky code or the ones that are most often used by your users or anything like it.
I find it funny that you say you shouldn't be just doing it blindly. To me, it feels like if I start using Cocoa, I could just as well quit my job because my OCD will kick in right away and I'll try to get to the 100% coverage.
Yeah, but it's getting tougher and tougher, and there's the opportunity to also manually validate pieces because they're impossible to reach or they are too hard to reach, so that there's an excuse as well. But I think what's more important is to just look at your relative success, because if you do a curve, it will reach some asymptote, maybe like 60% or 80%, and it's getting tougher and tougher, but you should have some rewards for relative improvements. That helps to motivate developers.
That's also, Cocoa supports, like I said, comparing releases together. And that's good for when you're looking at coverage between the releases so that you're achieving incremental coverage and not just looking at, okay, it was easy to get to the first 50% coverage and now it's really hard to get to the next 10% coverage or something. And if you're comparing candidates together, it's easier that way.
Yeah, and there's even a patch analysis. I don't recall whether you mentioned it. So you can throw in a source code patch generated by Git, for example, and it will tell you exactly whether the lines changed by the patch are being covered or not. And that helps you in this relative mode because you can ignore all the rest that may never be tested, but at least the requirement is there or the incentive to at least test your changes. Another topic, I think we skipped that completely since we are talking to Qt developers here. There's of course also the issue of QML code, and that is also being supported, although it's partially crazy because QML is full of declarative stuff mainly, and those things are just statically right or covered when the application is started, but the dynamic parts of it, so the JavaScript inside of the handlers, the properties, or global ones can be covered the same way and included in a single report later. And that's, of course, something specific to Qt that will always be special as long as QML exists.
We talked about, or you talked about the issue of getting just the top 10 test cases to run because you didn't have time to run your whole test suite, which led me to another train of thought, namely, how much are my execution being slowed down by Cocoa?
Yeah. So we typically see a 10 to 30% slowdown when from our benchmarks when using instrumented builds. That can vary, especially if you're using more complex code metrics like MCDC.
But it's not Valgrind style or anything. It's,
you know exactly where I come from.
No, it's not an emulation. And indeed, one could do it, but it's really based on the C++ level and the compiler, so that's pretty fast.
Mm-hmm. Mm-hmm. Can you give me, Harry, just an order of magnitude idea? What is our testing team looking at prices for Cocoa? Is that per tester or per line of code that it needs to run, or?
Line of code sounds like a really cool suggestion that we should pick up, or per execution. No, it is a per tester or installation license that can either be done in a node-locked manner for fixed seats or as a floating one if you want to supply a larger team. So let's say the starter package is 3,000 euros for 5 installations included.
Okay.
But yeah, it's something that is really appealing to the developers themselves. And what we are also currently experimenting with is to integrate that with Qt Curator, for example, or Visual Studio or Visual Studio Code to have it really show up while you write the code. So not just have an external tool.
Mm-hmm. And how about how well does it fly? And is that a concern that I should have if I'm using tools like CL Cache or Ice Cream or CC Cache or the like?
Yeah, no, it cooperates with those as well, because it is really just a front end to the compiler. So you will then cache that front end as well. So that's not a problem. Yeah, so even debugging or whatever, it's also possible. We would just recommend not to ship your final product in that way because of the small speed penalties there are.
Mm-hmm.
And also that approach also means that you can do the embedded testing, which wasn't shown here, or whatever. Cross compilation works in the same way.
Mm-hmm. And question that right away got into my brain, but you guys must of course have thought of it. But you mentioned, Nick, the idea that you have this test that you want to send out to a bunch of different parties that do not have access to the source code. It's called the source coverage. Well, the result of running the test, will they be merged together, those result files, or?
So that's black box testing, and in that case, you have you send out the instrumented build to the QA team, and they run everyone in however many they are run their tests, and they output an execution report, and they can load those into the black box database to view the execution report, comment on it, things like that, and view the time that it takes. When you take those reports, the master developer or the developer with master access to the source code can merge them together along with the view of the source code and view the efforts of everyone on the team.
But you're completely right, Jesper. This is a good idea, but it's for some reason not really being used widely, because there are the developers who do that in their lab. There's maybe the QA team who does some acceptance testing. But why not deliver this to some crowdsourced approach even, and just pull everything together and maybe even control how those controlled outsourced testers are doing their job? There's of course some privacy issue behind that, but that all is thinkable.
Well, I'm also thinking about open source software. First of all, do you have any support for open source licenses, or?
We are quite generous and are handing out free licenses for such projects. Yes, actually, we're also running a site, opencoverage.net, where we have demoed that ourselves 1 or 2 years ago, where we did that for Qt. Oh, there's Qt coverage available, of course, but we did that for OpenSSH, OpenSSL, and to our surprise, the Qt test coverage is way better than, for example, OpenSSL. And although we all rely on that, and we started that when the Heartbleed bug came up, because I wondered, is that code properly tested or not? And that was the initiative back then.
Scary, but very interesting.
Yeah. And also integrating that into the review process, or ideas floating around like Gerrit or whatever system is being used to qualify the patches that are being submitted.
Thank you very much. Thank you, Nick. Thank you.
Bye.